Hello, ladies and gentlemen. This is Dr. Robinson, and we are going to continue our studies. This time we're talking about formulas for area. So here's our first formula. It's square. So the area of a square is side times side, or we say A for area equals S squared, and S stands for side, because the sides of a square are the same. So side times side, that would give us the inside space of the square. We have a rectangle, parallelogram, and rhombus. So here's the rectangle, and here is the parallelogram, and here's the rhombus. They all have the same formula for area, finding the area. The area is equal to the base times the height. We say A equal BH, B times H. Our next formula for area is the area of a triangle. Area of a triangle is 1/2 base times the height. Or we say A equals 1/2 B times H. And here is our bottom length of the triangle, and our height is the straight perpendicular line that goes from the bottom base up to the top vertex, and that's the height. Our next formula for area is a trapezoid. Notice the area formula for this one is a lot longer. It's the longest formula in area because the trapezoid is a long word, and that's how I teach my students to memorize it, so it's a long formula. So it's 1/2 times the height times base 1 plus base 2. So the trapezoid has two bases. I want you to notice, because if you flipped it, rotated it upside down, you could sit it on the bottom base as well as the top base here. So base 1 and base 2 can be added together to give us one base, and then multiply by the height and take half of that. So the area formula is A equals 1/2 times height times base 1 plus base 2. So remember, add the two bases first, then multiply by height and take half of that. The next formula for area is circle. Our circle formula is area equals pi times radius squared. And the radius is the segment that goes from the center of a circle to the edge of a circle. That's called the radius, and it's half of the diameter, by the way. So we have pi r squared. Area equals pi r squared. So here's a question. Let's give it a try. A banner is shaped like a triangle, like the triangle below. What is the area of the banner? Well, here we have the base of 9 centimeters, and we have a height going up from the base to the top of 5 centimeters. If you remember the area formula for a triangle, it's 1/2 base times height. So let's add that to our notes. Area equals 1/2 base times height. So 1/2 is going to be multiplied by the base, which is 9, and that'll be multiplied by 5. All right, 1/2 times 9, I believe that is 4.5, and then we're going to multiply that by 5. And 4.5 times 5 gives us 22.5. So I will go with choice B, 22.5 centimeters squared, or square centimeters. So again, the formula is 1/2 base times height, so 1/2 times 9 times 5. So that will give us 22.5. All right, that's a good question. Here's one for you. What is the area of a parallelogram with a base length of 12 units and a height of 9 units? Remember, area equals base times height when we have a parallelogram, so maybe that'll give you a little help. Check your understanding, see if you understand so far. If you do, great. If you don't, just write down your questions and bring them in the class tomorrow, and we'll talk about it. Oh, here's an interesting question. There's Carlos. He cut two triangular boards from the corners of a rectangular board as shown by the shaded sections below. What is the combined area of the shaded sections? So they want the shaded regions here. Here we have a 5 centimeters on the side here and a base here. We have 10.5 centimeters. Now I noticed it looks like a triangle in the middle of this rectangle. So we need to find the area of the rectangle. So remember, area of a rectangle is length times width, which is 10.5 times 5, and that'll give us 52.5. So that's the area of the rectangle. So if we had the whole area, all we would have to do would be to cut out a triangle from that. And that would leave us with these two shaded regions. So let's find the area of the triangle. Now, the triangle, I notice I have a base, but I don't have a altitude dropping down. So let me get a line tool and show you that you really do have a height. This distance here, if I were to slide it, it would be the same distance right there. So I would have a height, which is the same at the side of the rectangle, and that would be 5 centimeters. So 5 centimeters is this distance here. So if I just slide it right here, that would give me the distance from the top to the bottom of this triangle. So I really do have a height. So I need to find the area of the triangle, which would be base times height divided by 2, or 1/2 base times height. And that would be 1/2 times 10.5 times 5, and that would give us 26.25. So now we have the area of the rectangle. We also have the area of the triangle. So if I were to physically take out that triangle from that rectangle area, I'd be left with these two gray triangle sections here. So that's what I'm going to do. I'm going to take it away, or take it out, to give me the shaded area that's left. So my shaded area, I would take the area of the rectangle, which was 52.5, and take away the area of the triangle, which was 26.25. And when I take it away, I'm left with 26.25, which would be the area of these two regions that are shaded. And that's a good problem when you have to find the area of a shaded region. So find the area of the bigger figure and take away the smaller figure from it. And that'll give you the remaining figure. Good question, Carlos. Here's another question for you. A window is shaped like a trapezoid below. What is the area of the window? Well, I want you to go back and look at your trapezoid formula and see if you can find the area. So I hope you got something out of the lesson. If you have questions and you're still uncertain, write them down, and I'll be glad to go over them in class with you tomorrow. So this is Dr. Robinson signing off. I'll see you next time. Have a good day. Bye-bye.